Hi, this video is an introduction to imaginary numbers. So let's get straight into it. Since the time of the Egyptians, when they were working on the pyramids, engineers and mathematicians and that sort of thing were playing around with numbers. And there were all sorts of different numbers they worked with, some of which they understood, some of which they didn't. Pythagoras, for instance, had a problem with irrational numbers. So let's just have a quick look at the number system and how the whole thing fits together. To start out with, we started out with the really simple numbers, numbers like 1, 2, 3, which were referred to as the set of natural numbers. So that was the first sort of group that we started out with. And then we added on naught. And so that gave us our next group, which was the whole numbers. And then we added on the negative numbers. And that gave us our next group, which were the integers. And then we added on the fractions, 1.5, 2/3. And they were called the rational numbers. They were Q for quotient, something divided by something. And then after that, there were numbers they couldn't write as fractions, and so they became the ones that weren't fractions, and they were called the irrational numbers, Q dash. And they're numbers like the square root of 3, or the pi is obviously a good one. E is another good one that we worked with. And this lot altogether became known as the set of real numbers. And then the work that Cardano and others did brought another layer onto this. And that was the set of imaginary numbers, and that's where we start to take things like the square root of -1. These are the imaginary numbers. And altogether, this big set is what we call the complex number. So, as I said, various people worked on the idea of complex numbers. René Descartes was the person that said, right, a complex number is going to be a number that's going to have two parts. It's going to have a real part, and it's going to have an imaginary part. And that's how we're going to make our complex number. That's what our complex number is going to look like. Euler, the famous German mathematician, he was important because he did a lot of the creation of the notation that we use nowadays. And he went and took this a bit further, and he said, right, if we're going to work with an imaginary number, or complex number rather, we're going to look at it like this. We're going to say Z, which is our imaginary number, and that's the letter that we tend to use. It's going to be made up of a real part plus an imaginary part. And that imaginary part is going to be a product of some real number multiplied by the square root of -1. And he said, right, because we're using this imaginary square root of -1 number a lot, we're going to call that, we're going to represent that by the letter I. And so we have this definition of what a complex or how a complex number is defined. As I said, this notion of complex number was explained graphically by the French mathematician Argand. And he looked at it this way. He said, okay, I want you to take a two-dimensional plane, like the XY axis, but I want you to think of the x-axis, the horizontal axis, being the real axis, and the vertical axis being the imaginary axis. So if I've got a number like this, 2 plus 3i, that means I'm going to go 2 along my imaginary axis, my real axis, because this part over here is my real part. So I'm going to go 2 along there. And then I'm going to go 3 on my imaginary axis, because that's my imaginary part over there. So I'm going to go up 3. And that's going to be my point over there, 2 plus 3i. And so we can look to explain an imaginary number in this way on a two-dimensional set of axes. So the number minus 2 plus I be minus 2 along the real axis, so that's going to come to over here. Plus I means I'm going to go up 1, so that's going to be my point over there, minus 2 plus I. Whereas minus 3 minus 2I will be 3 along the real axis to the left, and then 2 down. So this is going to be my point, minus 3 minus 2I. And so we can uniquely plot the positions of these complex numbers using this Argand plane. Now, we need to think about the basic operations that we use with complex numbers. So when it comes to adding or subtracting them, all that you're going to do there is you're going to add the real parts together and you're going to add the imaginary parts together. So here I'm going to add 2 and 3 because those are my real parts. And then I'm going to add my imaginary parts of I and 2I. And that's going to give me a number that's going to be 5 plus 3I. And there I've added my two complex numbers. If I were to take them away, I'd follow exactly the same process. So this is going to be 1 minus 3 because those are the two real parts that I've got. And then I've got imaginary parts over here. So that's going to be plus 2I minus 5I. And so I can think of this number now, once I've simplified this out, as being minus 2 minus 3I. And so we are able to add and subtract complex numbers. Multiplying complex numbers, well, we're going to use the same approach that we would use when we multiply two binomials together. So whether you call it the happy cat method or the FOIL method, we're going to multiply everything in the one bracket by everything in the other bracket. So I'll do my firsts. So I'll have 2 times 3. I'll do my outers. That's going to be plus 2 times 2I. I'm going to do my inners. That's going to be plus I times 3. And I'm going to do my lasts. That's going to be plus I times, oopsie, not 3I, plus I times 2I. Now, if we tidy that up, what have we got? I've got 6 plus 2 lots of 2I means I've got 4I plus 3I. And here I've got plus 2I squared. I've got 6. 4 plus 3I gives me 7I. And now I just need to be careful here. I know that I is the square root of minus 1. So in other words, I squared is going to be simply the number minus 1. So what I have over here is 2 lots of minus 1. So this is in fact going to end up as being minus 2. And so my final answer, give ourselves a bit more space here, my final answer is going to be, why didn't you shift on? Is going to be 6 minus 2, that's going to be 4 plus 7I. And they have multiplied two complex numbers together. Division. Well, when they're dividing two numbers, I can think of them as a fraction. So in other words, I can write this as 2 plus I divided by 3 plus 2I. And just as we did when we were rationalizing the denominators of surds, if I want to tidy this up, I'm going to multiply it by not 3 plus 2I, but 3 minus 2I. I'm going to do that because it will create a difference of two squares in the bottom line, which will be something that will be quite useful. So from the top line, I've got 2 plus I times 3 minus 2i. So if I multiply that out, that's going to give me 6 minus 4i plus 3i minus 2i squared. And on the bottom, can you see I've got the difference of squares format? The elements inside the brackets are the same, but the signs are different. So I'm going to have 3 times 3, which is going to give me 9. And then I'm going to have minus 2i squared. If we tidy up the top line, we're going to get 6 and 3, which gives me, that's 3i, by the way. Well, what have I got here? I've got I squared again, so that's minus 1. So I've got minus 2 times minus 1, which is going to give me plus 2. So that'll give me 8. And here I'm going to have minus I. And on the bottom, I'm going to have 9 minus 4i squared. In other words, I'll have 8 minus I over 9 plus 4, because I squared is minus 1. And that's going to give me 8 minus I over 13. And so I've been able to divide two complex numbers together. Right, you need to now go, that's all I'm going to do is my introduction. You now need to go and practice some of these. Goodbye.